Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight is one of the grad students who works in the Planetarium, and I will let her introduce herself.
Hi, I'm Lindsay.
So tonight we're going to be taking a look at kind of some of the tools that astronomers use and ways that you can use those same tools to investigate things at your own home, even do some astronomy for yourself. And this is all leading up to our Astronomy Day coming up this Saturday, which we're very excited for. And so we're going to take a look at a lot of the things that we're going to talk about tonight. We are giving out in our activity kits for Astronomy Day the items that will help you achieve the things we talk about tonight, if that makes sense. So, as always, if you have any questions throughout the show, you can leave them down in the comments. We'll be keeping an eye on those, and we'll try and answer them as we see them. Remember, there is a little bit of a delay between when we see comments and answer and when it actually comes across on the stream. And if for some reason we don't get to your question right away, we will have time at the end that we will make sure that we get all of the questions answered. So I am going to switch on over. That one. There we go. And so a lot of what we're going to be talking about tonight is, as I was saying, how astronomers observe and study the universe. And of course, the really only way we have to do that is by looking at the light that comes from objects, because we can't go to a star and collect a sample and bring it back. We really just look at the light that's coming from it. And thankfully, that light coming from objects tells us a lot of different information. So we're going to look at, in particular, two different tools that astronomers use to try and decipher that information that's coming from the light. But first, let's talk a little bit about what exactly light is, because if that's what we're studying, then we need to know, of course, what exactly it is. So the sciencey, complicated name for light is electromagnetic radiation. Um, you will hear that said a lot because light, as we use the term in everyday speech, tends to be more associated with light that we can see with our eyes. But light itself, the full electromagnetic radiation, comes in more types than just what we can see with our eyes. We can only see a very small range that we call the visible light because it's visible to us. But there's lots of other types from radio waves, infrared, and then ultraviolet, X-ray, and gamma. And so we tend to classify the type of light based on a few properties that are all interrelated. So one of the things we use is something called wavelength, and you can see that demonstrated here at the top. It's really just the distance from one peak in the wave to the next, because light is a wave. It's a wave of energy. And so we have in our visible light, red light is the longest wavelength visible light, and the purple is the shortest. And then going beyond visible, infrared and radio have longer wavelengths, and X-ray, UV, X-ray, and gamma all have shorter. This is also associated with energy, and you can see that, that the shorter the wavelength, the more energy is carried by that type of light. The longer the wavelength, less energy. And so when we're talking about light in astronomy, we're talking about all the forms of light, not just what we can see with our eyes. And so one of the things when we say take a picture of an object that we're looking at, there's a lot of information just in the picture itself. And the way the light is distributed tells us how the object that we're looking at, how it's distributed around space. You'll also notice that there are a lot of different colors here. And color is another thing that can give us a lot of information about what we're looking at. But there are a few different ways to interpret color. So the first way we're going to talk about is more akin to how we see color on an every day-to-day basis. So when you look at something yourself, say at home, the reason you see it as a color is because that's the color light that is bouncing off of that object and making it to your eyes. So for example, here we have this nice shiny red ball. So what's happening is when light hits it, all of the other colors that hit it are absorbed, but red light is reflected, bounces off the ball, and that's what makes it to your eye. Since we only see red coming from the ball, we see it as red. Same thing happens with the green leaves on the tree. All of the other colors except green are absorbed. Green is reflected off, makes it to our eye, and so we see it as green. Now the colors black and white are interesting cases. Objects look black because they actually absorb all of the colors and none are reflected back. And white is the opposite. It absorbs none of the colors and reflects all of them. So all of the colors end up at our eyes. And that's where it's really interesting. The fact that we see all of the colors combined as the color white is really just something in our brains that's the signal that it sends us when it receives all of the colors. It like mixes them and tells us, hey, that's white. And so that's what we see. And a lot of things in space are colored for the same reason. Great example is the planet Uranus. It is this beautiful kind of bluish, greenish color, and that is all from the different types of light that are reflected or absorbed when it hits those cloud tops there on the planet. So in this case, everything but the blues and greens are absorbed, and those blues and greens get reflected back to our eye, and that's why we see the planet the color that it is. And so if we go back to this picture that we started off with, the blue colors that we can see coming from in our image here, those are very similar to say Uranus there. What we're seeing here is gas that is bouncing the blue starlight from a star that's nearby. That blue light from the star hits the gas and dust and it bounces off of it and comes back to our eyes, or in this case to our camera. And so that's why we see these regions as blue. They're reflecting the blue light from a star. Now, when we are looking at things, especially if we're wanting to look at different colors, yes, you can do it in this sort of way, where we see all of the colors at once. Or we can do something else to really just isolate a single color, or even isolate a specific type of light that we want to see. Because again, there's more light out there than what we can see with our eyes. And in some cases, that different type of light can actually reveal things that we don't see in visible light. And a great example is this picture over here on the right, where in visible light, this area looks black, dark, like there's nothing there. But when we look in infrared, we see that there are actually stars back there. And so these different types of lights allow us to see things that weren't there. But we also do this with something called filters. So the idea is, instead of taking a single one color image where all of the colors are coming in together, we put on these little filters here, and that blocks all but a specific color from getting through the telescope. And so if we put a blue filter, then the only color that comes through is the blue color. And so it specifically shows us where the blue is coming from. And we can do that with any color that we want. And this allows us to better study exactly where specific color is coming from. And this could be important in the case here with like this galaxy. The blue light is associated with young stars. And so by looking at just the blue light, we're able to see where young stars are in the galaxy and therefore where star formation is taking place. Red light tends to be more associated with gas and dust. And that can tell us where that gas and dust is within our galaxy. And so these different colors let us examine different parts more easily by looking at just the specific color. And you don't have to have these fancy filters to do this. Oh, I forgot I added this example. Another thing you'll commonly see is the sun with the sun. When we look at the sun in different colors, different types of light, we see different features. Again, another use for looking at a specific type of light. But as I was saying, you don't have to have fancy astronomical filters to explore this at home. Really, all you need is a transparent sheet that is colored, kind of like these. And they act exactly like those astronomical filters. If you hold up a green filter to your eye, only green light is getting through, and you'll be able to see where green light is coming from and look at that. And so this example is showing these different filters when you're looking at, say, an apple. And so we can see that, of course, the red of the apple comes through the red filter. Green doesn't, because green isn't red. And so we see just dark there, because there's no red light coming from it. And then we have the opposite with the green. There's no light coming from the main apple part because it's red, not green, but we see it from the leaf. And then in blue, there's no blue light coming from either of them, so they both look dark. And so you can have fun and learn about the different colors of light coming from objects just by using these little transparent colored sheets. And of course, there's lots of fun that can be had with them. You can draw pictures that change depending on what color filter you're looking through. And so in this case, this was made with both kind of a blue and a reddish color. And so when you look through the red filter, it's actually interesting. You might think that you should only see the red when actually the blue is showing up. And this is because it's been drawn on a white piece of paper. Remember, white is all colors, including red. So we do see red coming from the paper as well as from the kind of pinkish lines. So they like blend in together and hide. Whereas we see the blue as really dark because there is no red coming from that. And so we end up seeing that as dark, and it shows up really well. And so you can draw pictures that change with the different color filters you look through. You can create secret messages by writing over in different colors so that different parts are seen when you look through different filters. It's a lot of fun to be had. And more than that, you can even do this going out looking at the night sky because stars come in different colors. And using these when you look at the stars can help you really see which stars are more red in color, which stars are more blue in color, because they will look different when you look through these. And so this is one of the activities that comes with the activity kits that we are giving out on Saturday. You will get your own set of filters and some crayons and some instructions on how to play around with these, learn how they work, and make your own kind of coded messages that you can send to friends. All right, so let's look at another use that we have for light. We saw in our pretty pictures that we can just look at an object and see either all of the light that's coming from it and get these full color images, or we can use our filters and look at just a specific color coming from the object. But another thing that we like to do is take the light coming from an object and spread it out so that we can easily see all of the colors coming without having to look at a specific, take a picture in blue, take a picture in green, take a picture in red. We take the light and we spread it out so that we can see all of that at once. And one easy way to do this is passing through something like a glass prism. And this helps to spread the light out, and we end up getting what's called a spectra. That's just a fancy name for the rainbow of colors that come from an object. And if you're wondering, hey, is that where our rainbows come from? You are absolutely correct. In this case, the raindrops, the water droplets in our atmosphere act like that glass prism. They spread that light coming from the sun. The sun gives off the full rainbow of colors. So when it passes through that water droplet, it gets spread out, and we see that full range of color, giving us those beautiful rainbows. And so when we do this in astronomy, there's a lot of cool information we can get. And this is getting back to where some colors come from. We saw that color in some case comes from the light that's being reflected or absorbed when it hits an object. And this is another example of what color can tell us. In some cases, color is actually associated with temperature. And the best example of that are stars. And we can see here that really hot stars give off more blue color, and cooler stars give off more red color. And so by looking at all of the colors that the star gives off, based off of how much of a particular color there is, how strong it is, that can give us the temperature of the star. Now you may also notice that there are lines here. These dark lines of missing color are what we call spectral lines. And these give us even more information about the stars. So it turns out that all of the elements, and more than that, all of the elements, the isotopes, the molecules, everything, they all have a unique color signature. And what I mean by that is they all give off a unique set of colors. And you can see that the specific colors that hydrogen gives off are different than helium, which are different than lithium, than beryllium. And so this is like a fingerprint. When we see a particular set of colors, we know, hey, that's given off by hydrogen. And so by seeing those specific colors coming from an object, we know what it's made up of. Or in another case, if we see that specific color missing, that also tells us, hey, there's hydrogen there. It's just the hydrogen is taking the light instead of giving it off. Where here it's giving off that light, here it's taking it. This is a really, really quick kind of explanation of this process we call spectroscopy. We have done a full show about this. If you're interested, you can always go check out our past videos where we did a full in-depth kind of look at what this is. But that's one of the reasons that we want to look at that full rainbow so that we can figure out what things are made of. And so back to this picture that we started everything with, the red color that we see in this image turns out to be the very specific color red that is given off by hydrogen. And so we know that that red that we're seeing in there is from glowing hydrogen. It's red light coming from hydrogen gas. And so we see that hydrogen gas all throughout our image, and we can kind of see where it is and how it's structured and all of sorts of things like that. We can, of course, do this with our own sun. If we take a spectra of the sun, it does have that full rainbow of colors as we see in our rainbow, but if you are able to look a little bit closer and a little bit more detail at the specific colors coming from the sun, you'll see there are some missing. And those missing colors tell us what the sun is made of. And that's how we know that it's about 3/4, yeah, that's the fraction. 3/4 hydrogen and about 1/4 helium, and a tiny little bit of other stuff. That's how we figured that out. And just because I always love giving her credit, the first person to discover this was actually Cecilia Payne Gaposchkin. I always mispronounce her name. Um, who figured this out back in 1925 and wasn't believed for, Lindsay, do you know how long it was? It was several years, right?
Yeah, I think it was at least a decade.
Yeah. No one took her seriously until a guy figured out the same thing and then was like, oh, hey, guess she was right. But she's awesome. You should definitely know her name. And so getting back to how you can do this at home, because I know this sounds like super fancy and like how could we ever actually do this ourselves? It's really easy. All you need is something that will spread light out. And it turns out a really good everyday item, or at least it may not be as everyday now. It was pretty everyday when for most of my life, and that's a CD or a DVD, because that CD and DVD has tiny little grooves. When the light hits it and they hit those grooves differently, that causes the light to spread out, and that's why you see that rainbow. And you can even get super fancy with it and make your own little, we call this a spectroscope. It's the device we use to look at the rainbow, to look at the spectra. And so you can make one with just a cardboard tube and a CD. Um, Another type of thing you can get, and this is something you would have to purchase, are these really awesome diffraction glasses that do the same thing. When the light passes through the glasses, it spreads out and you can see that full rainbow. And so using these very simple items, you can take a look at lights all over your house and take a look at the different colors coming from these lights. You may find your kitchen light gives off the full rainbow of color, whereas this kind of aqua blue light that's in, I believe that's my husband's computer. I don't think that one's mine. You can see where that you have those blues and greens because it's an aqua color, that's blue-green, but there is also a little bit of red in there. And if you really take a look at a bunch of light bulbs in your house, you may start to notice that they don't all look the same. And it turns out they don't, depending on what they're made of. They give off different types of light. And so you can kind of explore that for yourself and see how these different lights vary depending on the type of light bulb that you're looking at. Or you could see the sun spectra. Now, I have to preface this. Do not ever look directly at the sun. Don't do that. Not with your little spectroscope that you make here, not with the rainbow glasses. It's not safe. It'll hurt your eyes. Don't do it. But thankfully, we don't have to look directly at the sun to see the sun's light. Because during the day, the sun's light is coming from us from all directions in the sky. That's why it's so bright in the day. And so you really just need to look outside, up at the sky, not at the sky directly at the sun, but just up at the sky somewhere. And you'll see that sunlight coming to you, and you'll see that spectrum, that rainbow of colors coming from the sun. And if you have good vision and a nice, bright, clear day, you can even make out some of those lines. And so you can be just like Cecilia and see those little individual pieces of color that are missing and know what the sun is made of based off of that, which is really awesome. So this is another activity that is included in our kits that we're giving out for Astronomy Day. You will get the materials to make your own kind of CD spectroscope like this, along with, of course, instructions and how to use it. But we're also including a pair of rainbow glasses, these diffraction glasses, because they're awesome and super fun. And I mean, who doesn't love seeing rainbows everywhere you look? Oh, So I just saw, this reminds me of Harry Potter with Luna Lovegood's glasses. I love that. She is one of my favorite characters. So I am totally taking that as a compliment. All right. Now, when astronomers use filters and spectra, what they're actually doing is they're attaching these things to their telescopes that they use to study the night sky and to study objects in the sky. And so we attach filters to the telescope, or we attach a spectroscope, which allows us to take the spectra. And so the really main tool that astronomers use are telescopes, because those gather the light coming from the sky and magnify it to either our camera or our eye, depending on how we're observing. Usually, if it's actual research astronomy, it's going to a camera, so that we can collect that light and study it later. And of course, most astronomers use these big observatories that are all over the world, but we do also have telescopes up in space that do this as well. One you may have heard of is the Hubble Space Telescope, but there are others, and they do look at different types of light, so not just the visible light that we can see with our eyes. But you don't have to be a fancy big time astronomer to have a telescope, because you can get one for yourself. There are three main types of telescopes. I'm not going to get into a whole lot of detail about the different types tonight. Again, we've done an entire show about this in the past that you can go and check out. But one thing I want to say is it's actually not that difficult to make a simple telescope yourself without having to go and buy one. In its simplest form, uh, the the refracting telescope, this one on the left here, is really just a tube and two glass lenses. And so that's all you need, a tube and two glass lenses. And you have yourself a very simple telescope. Now, the exact type of lens, there's details in there, but hey, we've got another Astronomy Day activity. Now, with the other two activities I brought up, those are included in the free kits. Our Make It Yourself Simple Telescope is not part of the free toolkits. We are offering these as an optional fourth for $10, because the glass lenses, of course, are a bit are not super cheap, and so we are not able to give those away for free like we are all of the other activities. But if you are able to, you can purchase that simple Make It Yourself telescope and have a very simple telescope for yourself. All right, and so that is Astronomy Day, and that is the tools that astronomers use and fun ways that you can incorporate this yourself at home. As I said, in those free toolkits we're giving out, we're going to have those filters, so you can explore filters and colors. We have the spectroscope and the rainbow glasses. And then the third activity is making a 3D model of the Hubble Space Telescope, since the Hubble Space Telescope uses these tools like filters and spectroscopes. And so you can make your own model and then learn more about it as well. And so, yeah, we have that coming up this Saturday. We're super excited. We actually just today spent, what was it, Lindsay? 3 hours, I think, about putting all of the free activity kits together, so they're all together, ready to go. And we're going to have demonstrations out as well. Lindsay's got some fun stuff planned with bubbles, which is going to be fun. We're also going to be raffling off a Lego Saturn V. So you can get your raffle ticket for that, and we'll announce the winner that night during our live stream component, during our virtual component for Astronomy Day. So yeah, hopefully this has, got you, let me go back there, um, uh, kind of a bit more insight into some of the tools that astronomers use, and excited to try some of these things out for yourself. And if you are in the Duluth area or going to be in town on Saturday, you can come by and get some of these tools for yourself to have fun being an astronomer at home. Lindsay, is there anything else you think we should add? Other than it's going to be super fun and awesome and people should come join us?
And then we'll have our virtual stream at 7.
Yes. And that
And
will,
that's a special 2.
yep, special 2 hour stream. We're going to have some guests on. So Bob King, or Astro Bob, as you may know him, will be on talking about the couple of eclipses that are coming up. We're going to have Jim Rock give a little talk. A member of the Arrowhead Astronomical Society is actually going to do a little mini talk all about telescopes and the history of telescopes, which I think is going to be pretty cool. And then Lindsay and Eli are also going to talk a little bit about some of the research that they're doing, because they are actively doing astronomy research using some of these tools that we have talked about. And so I thought it would be fun for people to kind of hear what real astronomy research is like. Plus, they're looking at black holes, and who doesn't love hearing about black holes, right? I mean, come on. All right, well, I'm not seeing any other questions or comments or anything. If you do have questions, now's a great time to leave them down in the comments. And I will tell you a little bit more about what's coming up. Oh, I forgot I had this up. So first, before we get to shows coming up, if you didn't see our post a few days ago, we now have new t-shirts out for sale. We have several new designs. We also are offering not just unisex sizes, but we also have women's sizes and youth sizes as well. And there are some short sleeve, long sleeve options, a few different color options. We're really excited. You can find the link in the video description to check those out. We're so excited that those are out. All right, so Saturday, of course, is Astronomy Day. We've talked about that. Next week, Lindsay is going to do furry physics and take a look at how physics is used in the animal kingdom, because turns out animals are physicists too. And then next Saturday is the fourth edition of our exploration series. We're going to take a close-up look at our sun, which is going to be a lot of fun. All right. Well, not saying any more. I think we'll wrap it up there. Yeah, we hope that you come out and join us Saturday. It's going to be a really fun day. We do have backup plans. If for some reason it rains, we will still be out. We still, but if you want to say a few nice words to the weather gods, that would be great too. But we're super excited. All right. Well, just double checking comments to make sure I'm not missing anything. We will wrap it up there. So thanks for joining us. We hope to see you Saturday, and have a wonderful rest of your evening. Bye, everyone.